Hello my good people, and welcome back to my channel or David Structure Hub. This is a place where you learn, build and innovate. Today I want to talk about unsymmetrical welded connection with axial load. So under this topic I will be talking about what is an unsymmetrical connection joint, the forces involved, and how to analyze such a joint to ensure safety and efficiency. So if you are a civil student or a practicing engineer, this video is designed to build your understanding and boost your practical skills. So welcome. As you can see, this is a joint. This is a joint, and this is an angle plate or an angle line. This is plate B. It is connected to this angle line and it is welded at length 1, as you can see, and also welded at length 2. So this one is a section. No, this one is a elevation and this is a section. So what makes this joint unsymmetrical is the distance from the welded part, which is B, to the neutral axis. As you can see, this distance A and B are not the same. So that is what makes this joint unsymmetrical. So under this, we will be able to design the joint. So the first thing to do is to calculate the length of the weld. And the formula for the length of the weld is force over strength of the weld. So the length is L1 plus L2. So that will be the length of the weld. And the strength of the weld is 0.70 times T. T is the thickness of the weld, and this is the stress of the joint in shear. So maybe I can talk about something which is very important when considering the joint design. So in welded joint, shear stress primarily occur along the weld, while tension act perpendicular to the weld, often in connected plates. So as you can see, this welded part, it is along that plate. Also, this one is along the plate. So we will use this strength or the shear stress to design such a joint. Again, something to note or something to determine is the value of length 1 and value of length 2. And how do you determine the value of length 1? With some moment at point B. As you can see, summation of moment at point B is equal to 0. So if we sum moment at this point B, we will have L2, which is this distance of the welded part, as you can see where my finger is pointing. So it will be L2 times the perpendicular distance is A plus B times A plus B minus L. L is the total length times A equals to 0. And then you make L2 the subject of the formula. So the formula to determine, or the formula that will assist you to determine the value of L2 will be length times A over A plus B. Again, we will sum moment at point A here. So if we sum moment at point A, we will have L1, this is L1 times the perpendicular distance which is A plus B minus L. L is the total length times B equals to 0. And then you make L1 the subject of the formula. So the formula to calculate length 1 will be L times B over A plus B. So we proceed to example 1. As you can see, a tie bar in a truss consists of a double angle section that is 100 by 65 by 10 millimeter. The bar is subjected to a load of 300 kilonewton as shown in the figure below. The bar is welded to a gusset plate using 8 millimeter fillet weld of permissible stress 115 Newton per millimeter square. Determine the joint design. Design the joint taking distance between the neutral axis and the edges of the angle section as 33.7 millimeter and 66.3 millimeter respectively. As you can see, this is the connection and this is the angle plate, and the welded part, it has length 1 which is slightly longer than L2. Again, we have the distance from the upper welded part to the neutral axis as A, which is 33.7 millimeter. Again, from the lower welded part to the neutral axis as distance B, which is 66.3 millimeter. The thickness of the weld is 8 millimeter, and this plate, it is subjected to 300 kilonewton. So this plate are two in number, 100 by 65 by 10 angle. So let's see how we can design such a joint. So solution, the first thing to do is to calculate the strength of the weld. So strength of the weld. So the formula for strength of the weld is 0.707 times thickness times stress in shear. So this one will be 0.707 times thickness. Thickness is 8. Thickness is 8 millimeter times 8, then times 115. So this is the permissible stress, 115. Then you get your answer. So the answer is 650.44 Newton. So that is the strength of the joint. So Newton per millimeter, that is the strength of the joint. After calculating the strength of the joint, what follows next is the length of the joint. So length of the joint. Remember, the length is the total length. So this one will be F over strength of the joint. The joint will be since we have 300 kilonewton acting on 2 plates, so we will take 300, then we divide by 2 to get the force that will be acting on 1 plate. So this one will be 150. 150 times 10 raised to power 3. We are converting from kilonewton to newton. And then we divide the strength, which is 650.44. So the answer is 230.61 millimeter. So length of the joint is equal to 230.61 millimeter. And we know that the length of the joint, so length is equal to L1 plus L2 plus distance A plus distance B. So to get distance, to get the total length of L1 plus L2 will be 230.61 minus 33.7 minus 66.3. So the answer is 130.61. So that is L1 plus L2. So we will use this length, L1 plus L2, which is 130.61, to obtain the length of L1, this length L1 and L2 respectively. So let's proceed. So let's begin with L1. So L1 is equal to B times L over A plus B. So what is B? Our B is 66.3 times L. L is this total length of L1 plus L2. So that is 130.61 over A plus B, that is 33.7 plus 66.3, which imply L1 is equal to so the answer is 86.20 millimeter. So total length of L1, it will be 86.20 millimeter plus the thickness. The thickness of the weld is 8 millimeter. So plus 8. So this one will be 94.21 millimeter. So that is L1. We proceed to L2. So L2 is equal to A times L over A plus B. So this one will be A is 33.7 times L is at 130.61 over 33.7 plus 66.3. So the answer will be 44.02. Remember to add 8 millimeter thick, so plus 8. So L2 will be 52.02 millimeter. And that is the end of that question.